Bismillah ar-Rahman ar-Rahim. The title of this lecture is Immune Response, and the objectives of this lecture is the definition of the immune response, the types, and vaccines. Immune response is the contact between antigen and the antibody that stimulate the immune system to react against this antigen, so it is called immune response. And the first contact of an exogenous antigen with an individual leads to generation of primary humoral immune response. The characteristics of this primary immune response: longer lag phase, and during this period the naive B cells undergo clonal selection, clonal expansion, and differentiation into memory and plasma cells. And log phase or logarithmic phase, which is increase in the IgM concentration. While the secondary immune response, which is the second type of the immune response, which is the second contact of the same exogenous antigen from its name, secondary, first attack, primary. And the secondary immune response generates secondary humoral immune response. And the characteristic of this uh, secondary phase characterized by shorter lag phase, which is the opposite of the primary, and second, rapid reach greater magnitude of IgG, while in the primary immune response is the IgM, while here in the secondary immune response the IgG, and last for longer time. This is because of memory B cells specific for this antigen are existed and the process of affinity maturation and the class switching are responsible for higher affinity to antigen and different isotype. The affinity maturation, we mean that the antibody binding the antigen with high affinity, and we mean by class switching that there is a switch from the IgM to IgG, يعني antibody or switching from the IgM in the primary immune response to IgG in the secondary immune response. So this figure shows us that the vaccine containing killed or weak pathogen, when this is the first exposure to this antigen, just lead to primary immune response, and it is characterized by the this is the bacteria, and this lead to stimulate the B lymphocyte, and third we clone B lymphocyte proliferate and differentiate into plasma cell and memory B cell, and the plasma cell will secrete the IgM, which is antibody binding to this bacteria, and this is called the logarithmic phase, while this phase, the lag phase, which is long lag phase, because during this phase that there is recognition of the antigen, there is proliferation of the B lymphocyte, there is differentiation of the B lymphocyte to plasma cell, and secretion of the antibody. So this is long period of time required for the recognition, differentiation, proliferation of the B lymphocyte. While in the log phase, that there is a logarithmic increase in the IgM antibody. And the secondary immune response, the first, the patient or the individual took vaccine, and during epidemic, when there is exposure to the pathogen, so which is this lead to secondary immune response. So there is enter the bacteria or pathogen virus to the body. So there is a memory B cell which is present and directly recognize this pathogen and directly differentiate into a plasma cell, and this plasma cell will secrete the antibody which is of the IgG. So this lag phase is required short time because the memory B cell is ready to recognize the pathogen. And this also figure show us that this is the lag phase with the primary contact with the antigen with the primary immune response. There is a long lag phase and the log phase increase in the IgM. While in the secondary immune response, when there is exposure to the pathogen, the lag phase is short and the log phase is higher and large amount of the antibody of the IgG isotype. Now we have the subject vaccination or immunization, and this immune response can be used in the vaccination. A vaccination used to provoke a positive immune response by an individual to various pathogenic microorganisms to confer protection. First, natural or called passive, like maternal antibodies, and active, like natural infection. So, natural divided into two types, passive and active. The passive, like maternal antibodies that the fetus took due intrauterine or through the breast milk, and the active by natural infection with the pathogen. The second type of vaccination, which is artificial, which is either also passive, like antibody against the hepatitis B virus. For example, the surgeon injured with a needle during operation, and he did not vaccinated with the hepatitis not vaccinated with hepatitis B. So we give him ready antibodies, which is called passive immunization, passive vaccine. And this antibody ready against the hepatitis B virus. And the active, like vaccination, for example, with tetanus vaccine. So comparison between active and passive immunization. What's the difference? Active immunization delayed before protection because there is required time for the recognition of the pathogen, for the differentiation, for the stimulation of the immune system. While the passive is act immediately because we provide the individual with ready antibodies direct injected into the individual. And the active immunization long-lived because it is infection, because it stimulates the immune system, while the passive immunization short-lived depend on the half-life of the antibodies, and uh, uh, only took a short period of time, like in the coronavirus, when give the patient a plasma that contain antibodies, and this is for short period of time. It's not need to protect the patient from the COVID-19 because the half-life of the antibody is short. And active immunization stimulates the immune system, so give a long-lived immunity, while passive immunity, no stimulation to immune system because the patient or the individual took ready and ready and antibodies and injected into his body. So we have new term which is called polyclonal antibody. Most antigen, as we mentioned before, possess multiple epitopes, and each one of these epitopes induce different B cells to proliferate into a clone of cells that recognize different epitopes. So each epitope of the antigen will stimulate a specific B cell and produce specific antibodies against this epitope. So these B cells secrete antibodies, resulting into a mixture of antibodies called polyclonal antibodies, because the antigen, as we mentioned before, consists from multiple epitopes, and when this antigen enters the body, lead to stimulate different antibodies, and each antibody is specific to each epitope. So this is called polyclonal antibodies. While monoclonal antibody, a clone of single B cell that recognize a single epitope, only single, you must pay attention, single epitope that secrete antibodies specific to single epitope. So it is called monoclonal antibodies. So there is difference between polyclonal, take care of this monoclonal antibody, antibodies against a single epitope, while polyclonal antibody, different antibodies against different epitopes of the antigen. And monoclonal antibody used for diagnostic purposes, used for the therapeutic purposes, for example, used against a specific CD marker, against a specific CD3 in the transplantation, give the patient with renal transplantation antibody against CD3 receptor of the T lymphocytes in order to suppress the immune system, and also in different immunological therapy used monoclonal antibodies. And some countries synthesized monoclonal antibodies against AC1 receptor of COVID-19 and used to treatment patients with COVID-19. And thank you.